Hi class, on to the mature stage of thunderstorm development. As you can see, there's a lot going on with the mature stage. Updrafts and downdrafts coexist in the mature stage. So the updrafts are going to be in the back portion of the cloud. The downdrafts are going to be in the front portion of the cloud. And so I wanted to start with, why do we have downdrafts? How did those downdrafts form? And when we left off with the cumulus stage of development, the first stage, I mentioned that the raindrops and the ice crystals were suspended within the cloud because the updrafts were strong enough. Well, you gain more and more and more water in the cloud, and you literally get hundreds, if not thousands, of tons of water in a cumulonimbus cloud. And that the weight of all of those water droplets in the ice crystals eventually become too great for the updrafts. And those then the water droplets in the ice crystals will start falling through the cloud and dragging the air with it and pushing the air that's below it out ahead, and you create a downdraft. Okay, so now we've got updrafts and downdrafts coexisting within the cumulonimbus cloud during the mature stage of the thunderstorm. As you create this downdraft, not only is it dragging air with it, but it's also going to draw in air from outside the cloud. And this air outside the cloud is unsaturated. Okay, so when you draw in unsaturated air from outside the cloud, you're going to get evaporation occurring. Evaporation is a cooling process. And I should have mentioned that this whole process of drawing unsaturated air in from outside the cloud, that's called entrainment. Okay, so when you entrain in unsaturated air, you're going to get evaporation occurring, which is a cooling process. By cooling the air, you're going to make it more dense. And by making the air more dense, the air is going to want to fall even faster. So you're going to create an even stronger downdraft. So when this downdraft now exits the base of the cloud, it's going to hit the ground and it's going to spread out in front of the thunderstorm. And I'm sure you have experienced this in your lifetime. You see a thunderstorm in the distance, and before the thunderstorm reaches you, you get this big gush of cool air. That's the gust front, and the gust front acts like a mini cold front. Okay, and so remember, this is you got a thunderstorm, so you need a source of latent heat, warm, moist air. That's the maritime tropical air. Okay, and so there's maritime tropical air in place in front of the thunderstorm. So when this gust front exits the base of the cloud and spreads out along the ground, it acts like a mini cold front, and it's going to force that warm, moist maritime tropical air to rise. And that literally becomes the start of the next thunderstorm. And so what thunderstorms do, although on a radar image it looks like one thunderstorm moving across the screen, it's actually a whole series of thunderstorms where one thunderstorm gives rise to the next thunderstorm, and when that thunderstorm reaches its mature stage, it creates a gust front, and that creates the one in front of it. And so thunderstorms are actually self-perpetuating, and so it's kind of a interesting concept that when you get a really strong line of thunderstorms, it just keeps perpetuating itself as it goes across the Earth's surface. All right, so what else is going on? So we also have at the top of the cloud here, we have the jet stream. Okay, so way up here, 45,000 feet in the summertime, you've got the jet stream. Okay, and what the jet stream is going to do then is it's going to shear off the top. Here's the top of the cloud. And this is going to create that very characteristic anvil top of a thunderstorm that you probably have noticed. with most thunderstorms. It's got this anvil top to it, and that's created by the jet stream shearing off the top of the cloud, because these cumulonimbus clouds are up there 45, 50,000 feet above the Earth's surface. Other things that we need to be aware of with cumulonimbus cloud and a thunderstorm is that we talked about this at the end of chapter 7 with precipitation, that if you get hail, the hail shaft will be here right where the updraft and downdraft are adjacent to one another. So an ice pellet gets caught up in the updraft, gets carried to the top of the cloud, gets caught in a downdraft, comes down, and adds supercooled water droplets on it, carried back up to the top of the cloud where it freezes. Back in the downdraft, you accumulate supercooled water droplets, get caught in an updraft, those supercooled water droplets freeze, and that keeps going on until the updraft can no longer sustain the weight of the hailstone, and then it falls. And typically that hail shaft is going to be right where the updrafts and the downdrafts are adjacent to one another. Now, last thing is that if a thunderstorm occurs, and this is a big if, but if it occurs, a tornado is going to occur in the back portion of the cloud. And again, this very rarely do they form, but if they do form, it's going to be back here on the back edge. So literally, you're going to get rainfall. That's the first thing that typically occurs in a thunderstorm. Okay, and then again, if it's a really bad thunderstorm with strong updrafts, if you get hail, that would be the next thing. And if things are really bad, the last thing would be the tornado. Okay, so that's the mature stage of a thunderstorm. Lots going on in terms of activity with a mature thunderstorm. So hopefully this gives you an idea, gives you a way of picturing what's going on with the mature stage of the thunderstorm. Okay, next coming up very briefly will be the dissipating stage.